Hello everyone, my name is Jordan. I'm a secondary science and math teacher and a longtime basketball coach, pivoting into data science. For my project, I put my basketball expertise to good use and developed a framework in Python to analyze the controversial concept of a hot hand using NBA shot charts. As an added bonus, I used scikit-learn to train a model with the information I collected to predict makes or misses. For this presentation, I'll be focusing on Steph Curry. To collect the data for my analysis, I used Beautiful Soup to script the shot charts found at basketballreference.com. The points in these charts contain details about each shot a player took in a particular game, and from this tooltip, I was able to scrape the data for each shot and organize each game into a sequential string of makes or misses. With this string of ones and zeros, I identified all the instances of a shot taken following a made shot and calculated the conditional fraction of those attempts. I then did the same thing for shots taken following a missed shot. The difference of those conditional fractions gives us a test statistic, which will act as our gauge of hot-handedness. If this number is abnormally high, the player will have made a much higher percentage of shots falling makes compared to shots falling misses, something that we might expect from a player with a hot hand. We aren't limited to looking only at shots falling a single make or miss either. We can take the same approach with streaks of different lengths. Now that we have a test statistic, we need something to compare it to determine if it is abnormally high or not. So to generate this null hypothesis, I took that string of ones and zeros and shuffled it so that the order doesn't matter anymore. After shuffling the string 10,000 times and calculating the test statistic for each random permutation, we can compare this original string to this distribution of random strings. In this case, we can see that this particular order of ones and zeros is actually on the hotter end of this spectrum. Even though this particular example provides evidence of a hot hand, at least for how we've defined it, this wasn't usually the case for Steph Curry. Generally, his shooting percentage falling makes was actually slightly lower than his shooting percentage falling misses, and very few observations demonstrated evidence of a hot hand. After becoming more familiar with this process, I still think the biggest issue with this type of analysis is how to quantitatively define a hot hand. I can already see a few issues with how it's been defined so far, so I'd like to explore more ways of framing this problem in the future. As previously mentioned, I extended this project by training a model with the information I collected about each shot in an attempt to predict makes or misses. To establish a baseline, I fit a vanilla logistic regression to the data I had already scraped from those shot charts. There's not a lot of detail here, mostly when and where the shot was taken and whether it was a jump shot or not. As expected, the model trained in this data wasn't very good. It only performed slightly better than just predicting the majority class every time. So I expanded my data wrangling efforts in order to find as much information about each shot as possible. The NBA Stats API provided some additional categorical features like what kind of shot it was or what zone it was taken from, but I also discovered there used to be some more advanced features that were only available for a few years before being taken down. Thankfully, somebody scraped this data while it was still available and put it on NBASavant.com. This data provided some really great details like how many dribbles the player took before they shot, how long they had the ball for, who the nearest defender was, and how closely they were guarded. With a lot more features to train the model on, the accuracy improved substantially. The model managed to accurately predict a few more misses than makes, but had nearly identical precision for both classes. Looking at some of the coefficients, we can see that the model was able to learn some pretty valuable insights. Understandably, being separated from a defender and having ample time left on the shot clock are strong predictors of a make. Conversely, the longer Steph holds the ball, the more dribbles he takes, and the further away from the basket he is, the less likely he is to score. To conclude, this was a really fun project, and I learned a lot along the way. If you'd like to hear more, I'd be happy to answer any questions, and thanks for listening.